Hello, my Calc 2 student. Today we continue our lecture, and today we talk about inverse function. I think it's all you study inverse function before, but right now we remember a couple of things about inverse function. Okay, first looking some example. Here's some relation between two sets. Let's go, this set is A, B, C. Other set is numbers 1 and 2, and function f, let's move my A from 1 and B for 2 and C for B for same point 1 and C for point 2. This is f. If I try making something, okay, let's go, it's function f, believe me. Okay, if I try make it my arrow is opposite. What you know about a red arrow? It's not b function because for point 1 you have two possible values, a and b. Okay, inverse function is means something opposite your direction what you did before. Try found, this means for this function is inverse function is not exist. See one more example. Let's go and say same point A, B, and C. Here I take it 3.1, 2, and 3. Move to, this is move to 2, and this is move to 3. And this is function f. And I build my function with a red arrow. This means doing opposite direction. And this is opposite direction function. We use this symbol. And it's called inverse function for function f. Okay, great, but you know function is not this kind of picture usually. It's good for understanding. Give it some strong definition first. Definition. If function gx, function who is f composite g, this means f from gx equal x, and g composite f, this means g from fx, and still equal x, then g we call inverse function, for f, and use symbol g is f negative 1. Okay, how we can see function invertible or not? We can use, if we have graphs, it will be more simple, because how we remember from our definition, we need one-to-one function. For example, I build something like this. This is fx is function because vertical line test show me any vertical line intercept my graph is only 1 point. But what happened if I use horizontal line? It's green one, you see? I have a lot of line who is intercept my graph more than 1 point. This means this function is not one-to-one, and this means this function is not invertible. Okay. Doing some example where this will be invertible. For example, this kind of function. It's not exactly horizontal, sorry. something like this. Or something like this. All these examples show us, it's horizontal line test. Intercept our graph, it's only 1 point, right? This means all these two examples show us as invertible function, inversible function. Okay, but how we can find equation for inverse function? Here we have some algorithm. An algorithm have a couple of points. First, write is your equation. Second, switch y and x. And third, solve equation for y. And then the result will be our inverse function. Okay. This is algorithm work only if your function inversible. Remember, first you need check. Example, I give you function. For example, function will be 3x minus 1 over x plus 4. This means first step, y equal 3x minus 1, x plus 4. Second step, we don't think anything, we only, when you have x before you write y, when you have y before you write x. X equal 3y minus 1 over y plus 4. Okay, great. And third, solve. How is solve? We multiply it by denominator, both sides. Distribute. Collect all one side. We have, for example, 4x plus 1 equal 3y minus xy. And then this will be and finally y equal 4x plus 1 over 3 minus x. You see, we found inverse function. Can we check? Yes, of course. For example, we need check composite function, and our old function and new function will be, let's call it gx here. And doing what? F composite g. This means f from 4x plus 1 over 3 minus x. How you remember what is f is? It's 3x minus 1 over x plus 4. This means 3 times 4x plus 1 over 3 minus x. Minus 1 over x plus 4. This means 4x plus 1 over 3 minus x plus 4. Okay. Algebra doing what we have here. We have 12x plus 3 minus 3 plus x over 4x plus 1 plus 12 minus 4x. Okay. And here we have 13x over 13. This means exactly x, exactly what you need. You can yourself checking J composite F, and you have exactly x2. Okay. Now we have one more very interesting fact about inverse function. Okay. If point A, FA is from graph your function, fx. Oh my god, what I'm right here. Fx, then point FA will be from graph your inverse function. And this means if you have some function and your graph, okay, how you see it's invertible function, but graph will be symmetry for line y equal x, and graph will be, I think it's there. Okay, something like this. And this is true for, this is line x, this is fx, and here is, for example, inverse. Yes. And about a relationship between function and inverse function, we have some theorem. If your function f is continuous, on the main, and it's the main, then inverse function continue for different domain. Domain can be different, it's no problem, but it's still continue. This is first fact. Second fact, if your function f is increased, then inverse function is increased too. Third one, if your function f is decreased, then inverse function is decreased too. You can see proving all these three factors coming from if graph this function. Graph function and inverse function is symmetry. This means if graph is continuous, this means it's continuous. There is just increasing. Inverse function, decreasing, inverse function. Okay. And last one, fourth one, is called this give us this kind of information. If f is differentiable and derivative this point is non-zero, then inverse function is differentiable to different. Okay. Then couple of example from similar your homework. Question number 8. We'll be solving something similar, but okay. I have function fx is equal 1 over 1 plus x, x greater or equal 0, and function gx. This function is 1 minus x over x, but here domain is x is positive, but less or equal 1. And I need to show as function is gx is inverse for function f, or f inverse for function g. You know, it's same information. Okay, f composite g, it will be f from gx. It's here will be 1 over 1 plus 1 minus x over x. Simplify, we have equal exactly x. Because composite is not commutative operation, this means we need checking g composite f. It will be 1 minus 1 over 1 plus x divided by 1 over, 1 plus x. No, I can write x plus 1, but okay. It's equal. Here we have 1 plus x minus 1 divided by 1, and here we have 1 plus x, and there we have 1 plus x. This is cancelled, and here finally we have x. Yes, this is function. One function inverse to another. Now, different question. Use horizontal line test to checking this function is invertible or not. Number 18. Function gc equal 1 over square root t squared plus 1. Here t can be any number. If you try make it graph, let's go this x and t, here's y. We have something like this. Where's 1? And you can easy check horizontal line test. Any horizontal line, if it's intercept our graph, intercept more than 1 point. Sorry guys, it's cell phone and try. Малика, я записываюсь. Okay, we continue work. One more example. Number 25, number 20, sorry. Number 20. fx, my function is 5x square root x minus 1. Equal is very scary. Okay. Here domain this function is x greater or equal 1. Remember, because inside root can be stay only non-negative number. And if you try build graph this function, it will be something for 1 equals 0, for 2 is equal 5, and continue. This means something like this. Oops, more than one line. Something like this. Can you see? any horizontal line intercept this graph, it's only 1 point. This means if for first example we say no, this function is not invertible. For second we say yes. Okay. Sometimes function is not invertible for all domain, but we can build inverse function for some part. For example, this is question number 42. It will be your function is, just a little bit clear here. Okay, your function is fx equal square root x squared minus 4. And if you try graphing this function, it will be for x greater than 2, you have something like this. For x lower than -2, you have something symmetry. But in the question, in the book, you have built inverse function for x greater or equal to. This means second part, it's not interesting for us. If you solving only for x greater or equal to, you can see this function is invertible. And now we can build our inverse function. Remember algorithm one I showed before. This means you have first y equals square root x squared minus 4. Second one is x equal square root y squared minus 4. And third one is solving this equation for y. This means x squared equal y squared minus 4. And it's mean y equal square root x squared plus 4. And this will be inverse our function. It will be square root x squared plus 4. If we go back for our graph, and if we try graphing this kind of function, like square root x squared plus 4, it will be something like this, right? And you see it will be symmetry for our graph. Oh, I'm sorry, it's not so pretty, but it's okay. Okay, guys, this is all what I talked today about this part. Doing homeworks and ask me questions.